So they have to have AG and a colon. So that's their first 2 points right there. Okay, that has to be there. And then we're going to go through the periodic table following that pattern of S, P, D, and F sublevel regions. So S is here with helium put over here. P is over here. D is here. And so we're just going to walk through we're going to follow the yellow brick road till we get to silver. Okay, writing our orbital notation. So let's see, we got 1s here with 1 orbital and 2 electrons. And there's 1, 2, 3, 4 points. 1 for the symbol, 2 for the box, and 1 each for the 2 arrows. So far we've got 1, 2, 3, 4, 5, 6 points. Okay? Okay? And there's 2s with 2 electrons, and there's 4 more points. And then 2p, 3 boxes. Alright, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more points. Okay? Well, just hang on. I'm just pointing out where the points are going to come from. The whole thing's going to add up to 80 points, and we're done. And all you got to do is count off a point for anything they get wrong. Anything they get wrong on this, they count off a point. I'm just showing where they come from. Every box, every arrow, every symbol is worth a point. Got it? All right, now I'm going to start sort of speeding it up here. All right? So here's 3s and 2 electrons and 3p and 3 orbitals, an electron in each one of them. Going back and pairing them up. So I've got 2 electrons in each one. And then we get to 4s. 2 electrons in 4s, 1 orbital, and when we get into 4s and we get through 4s here, then we're dropping back 1 primary level when we get into this D sublevel region. So we go from 4s to 3d here. And those are going to be completely full, so that's 3d. 1, 2, 3, 4, 5 boxes, filling up the boxes according to the school bus rule, 1 in each seat or 1 arrow in each box, and come back pairing them up. Okay, and there's 3D. Then 4P. 3 boxes there. 1, 2, 3, 4, 5, 6 electrons. And then we go to the 5th primary level, and 5s. S is always the first sublevel you come to. 2 electrons there. So we're 1, 2, 3, 4, 5. We're in this row right here where silver is. So after we fill up 5s, we're going into 3D. I'm sorry, 4D here, okay? Now I made a mistake there because I don't have to move that arrow here in a second. Well, I made a mistake in using a permanent pen. I should have used a pencil. It's not really a mistake yet, but I'll have to use whiteout instead. So 1, 2, 3, 4, 5 boxes. And we need 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons here to get to silver. 1, 2, 3, 4, 5, 1 on each box, and go back and pair them up. 5, 6, 7, 8, 9. But this is where we've got an almost full D sublevel, so we have to pull an electron out of 5s. Okay, so I'm going to take this electron out of 5s here and move it down and drop it into 4D to finish filling up that 4D sublevel. That's close enough, I guess. Alright, so there we go. And that's the orbital notation for silver. So all together, there's 80 points there. Anything they didn't get right, they got extra boxes, count off a point for each box. Got extra arrows, count off a point for each extra arrow. Their boxes aren't lined up right, count off for every one that's not lined up right. Okay, symbols aren't written out right, count off a point for every symbol they don't have right. Okay, and add up all those points. Okay? Or add up the points. You can subtract the points they get wrong if you want to from 80 to get the points they're going to earn. Okay? Alright, then I ask you to do the first 2 quantum numbers for the 40th electron. Was that right? 40th? Okay. So let's count to the 40th electron then.
I have a question.
Yes.
If you just wrote, if you already wrote that down in your homework, like you wrote the AG,
Yeah.
and then you wrote down quantum number but didn't rewrite that, would you take off points? Like, you know how you have to count it?
Yeah. No, you don't have to recount it. I'm just I mean, I just have to find the right electron to write the. I'm just trying to find the right one. Okay. Remember, quantum numbers are the addresses. So this is a kind of inventory system for keeping up with all the electrons. Quantum numbers are kind of like addresses for each individual electron. We're going to find the 40th one and write the first two quantum numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. There it is. There's the 40th electron. Okay, so there's our 40th electron right there. All right. So we want the first two quantum numbers. They're symbolized by N and by L. Okay? And N is the primary energy level the electron is located in. And it's located in the fourth primary energy level. That coefficient 4 right there tells you it's in the fourth primary energy level. So N equals 4. Okay? L tells you what sublevel. When we're doing orbital notations, and for that matter, electron configurations, D, S, P, those tell you the sublevels. But we use a number when we're using quantum numbers. And in the quantum number system, S's are always 0, P's are always 1, and D's are always 2. So the two quantum numbers are 4 and 2. Okay?